Okay, welcome back to my third installment of Exponents. Today we're going to cover division. So previously we had talked about multiplication. In a multiplication, I told you to think about adding the exponents. Division, we do the opposite. We're going to subtract. So, let's just say we had x to the third power over x squared. So, a problem like this, you would take your numerator and subtract it from your denominator. So since both of these have x as your basis, you take your numerator, which is 3, subtract your denominator, and you get x to the first power, or just x. Those that visually like to see this x to the third and x to the second is the same as saying you're multiplying x 3 times on the top, 2 times on the bottom. So what I want to do is I'm going to cancel each pair of x's, and what is left? Your x, which we showed right in the first one where we subtracted the exponents. So maybe you have 4m to the 6th over, say, 2m. So in this case, what we need to do is we could say 2 goes into 4 2 times. Then we take our 6 that's on the top, and since m does not have an exponent, it really does. It's an understood 1, so you would subtract 1, and now you would get 2m to the 5th power. What about if I give you a problem, 3m to the 7th over 6m to the 5th? So what I would want you to do is break down to 3/6, and then you could say m7 minus 5. Now, the 3 over 6 reduces to 1/2 m squared, or we could write it as m squared over 2, either way. What happens if you have, say, 8n squared over 2n to the 5th. Now this is where it kind of gets confusing, because what I want to show us are two different ways how to approach this. One is 2 goes into 8 4 times, but then you would say n, and then you'd say 2 minus 5. 4n to the negative 3. Now, in math, we do not like negative exponents. So, I'm going to come back to this here in a second, but I want to show you all this visually, so this will make a little bit more sense. So that 8n, so n squared is just 2 n's. Then 2 into the 5th is 5 n's on the bottom. Now we take the same approach. 2 goes into 8 4 times. But now watch this, I'm going to cross out, and look what I get n at. N is on the bottom or in the denominator. So this would be your answer. Now, going back to the top one, I'm going to finish the way this. I would put this over 1. Anytime you have a negative exponent, you bring it down or up depending on the position, and this turns out to be 4. N goes on the bottom. When you put it on from the numerator to the denominator, that turns positive, just like our answer that I did on the second way, how to do it visually. Now let's add a little bit more to this just so we can understand it. Let's say you have negative 6 m to the 4th, n to the 5th, p to the 6th, and we put this over, say, 12. We'll say m into the 5th, p to the 10th. Now, a lot of times when students see a problem like this, we tend to shut down because there's a lot of things going on into this problem. We've got some numbers. We've got 3 different variables. We've got m, n, and p. So let's use my first method. Let's take negative 6, 12. Now let's look at our m's. Right here. I've got 4 minus 1. I've got n, 5 minus 5. And my last one I've got p, 6 minus 10. Now the negative 6 over 12 is negative 1/2. 4 minus 1 for my m is m3. My n's right here cancels each other out because n to the 0 is always 1. So we don't need that anymore. The n does cancel away. It turns into a 1. And now look at this. P to the negative 4. So that's going to be negative 1m to the 3rd. I'm going to put that over 2 because that is my denominator. Now, since my 4 is negative, I'm going to put this, I'm going to kind of drop this, and I'm going to make this p to the 4th. Now, as far as visually looking at this one, so I've got negative 6, and then I've got M4, N5, P6 over, then I've got 12M, so 12M, N5, P10. So now as far as visually is concerned, that is like saying negative 6, 1, 2, 3, 4 M's, 1, 2, 3, 4, 5 N's, 1, 2, 3, 4, 5, 6 P's. Then I've got 12, I've got 1 M, I've got 1, 2, 3, 4, 5 N's, then I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what happens is this right here, I've got a -1 because 6 goes into itself 6 times. I'm going to put it over. 6 goes into 12 2 times. And then I'm going to say 1m cancels. What's left? M3. Then I'm going to say 1 pair, 2 pair, 3, 4, all 5 cancel. I do not need anything for my n. And then my P1, 2 pair, 3 pair, 4 pair, 5 pair, 6 pair. That leaves me with 4 P's. And look at the position. It is on the bottom. So our final answer would be written as, you could say, -m to the third over 2p to the fourth. I hope this has helped us with dividing exponents. Please stay tuned for my next installment of exponents and using the power rule. Thank you very much.